Hey everybody, welcome to another Avalanche Developer Community Call. My name is Gabriel Cardona. I am a developer evangelist here at Ava Labs, and I am joined as always by some engineers from our amazing platform team. We want to talk about the recent Cortina 4 upgrade and some other potential exciting things that are happening on the Avalanche engineering team. So welcome gentlemen, and as usual, I'm going to hand off the microphone to Pog to take it away.
Thanks, Gabriel. All right, good to see you guys again. I'll share my screen and talk about the latest here. Hopefully, I don't have to restart my browser. All right, if you could share that for me, cool. All right, so yeah, earlier this week, released the Cortina 4 upgrade. For people that have been following along, you may have seen a number of release candidates that were publicly tagged along the way as we were testing different aspects of this. So maybe Stephen, you want to talk about exactly what we were testing and what we added to to allow us to test things.
Yeah, so I guess I'll probably start first with just the namesake of the release. So the namesake of the release is the Exchange DB cleanup. So the Exchange, of course, before Cortina was a DAG. So there was a whole lot of stuff that needed to be persisted on disk specific to DAG-related consensus, specifically transaction statuses and various UTXO things. So all of that stuff can get deleted now to clean up just kind of some of the database indexes, but also to free up some space on disk. So this is kind of going through, and on the first startup, it'll go through and iterate over these now unused indices and clean them up and delete them. So should see a little bit of an increase in DBIO and CPU usage for like the first couple or the first run, but after that, it should immediately just say like, oh, already pruned and move on. Going forward, we will keep this pruner in the background up until the next network upgrade, so 111. And then after 111 is activated, we will assume everyone has cleaned up their databases and removed this, which is the standard kind of flow for database like batch cleanup operations for us. So but yeah, one of the really cool things that we added into this is actually state checksums. So in the I believe it was 1912 regression, we saw a bug where we weren't deleting UTXOs correctly for a specific type of transaction on the exchange, specifically the operation TX. And the reason that didn't kind of come up earlier in testing was because we don't actually Merkleize the state on either the X chain or the P chain. And so there wasn't like an easy way to tell like a discrepancy on disk. So we still didn't introduce state Merkleization for either the P chain or the X chain in this release, but we did decide to do is introduce an optional state summary or checksum, which can be optionally configured on both the P chain and the X chain in the P chain and X chain chain configs to essentially output whenever a block is accepted what the state checksum is after accepting that block. So we were able to use this really extensively to make sure that all the background pruning that we were doing was still resulting in the correct disk state at the end of the day. So going forward, we're going to use this a lot internally to verify all of our like release candidates, especially anything that changes either verification, accept, or database logic on either the P chain or the X chain. But yeah, I think those are kind of the two big things that I'm really excited about, kind of on a stability and monitoring perspective in this release. We also fixed a very kind of subtle bug in bootstrapping in this release. So I think that there was only one person that reported this issue, but might be that there were other people that ran into it. But essentially, there was a really subtle bug in the proposer VM, which is the thing that backs Snowman++, and how it exposed the inner chain and the outer chain for the proposer VM headers to the consensus engine, which could result in a bug in bootstrapping that would cause the node to essentially fatal on startup. So that was also fixed in this release. Yeah, so that's a great kind of like really subtle consensus fix during the bootstrapping flow, which is nice. I think those are the main things that I wanted to point out. I don't know if you had other thoughts, or Aaron.
Yeah, I mean, I think the other thing, at least, I know, Aaron, that you may want to cover one of the C chain regressions we found in that API, but one of the other things that's kind of happening in the background here is a lot of Merkle DB hardening. So if you're following along on GitHub, you can thank Dan for a lot of that. But for people that haven't listened lately, is the Merkle DB is our like Merkle path-based radix tree implementation that currently is used for state management on the HyperSDK, and then will be used for state management on the X chain and P chain, and maybe the C chain. We'll see. But if it's going to be so important as the center of everything that's going on, right? Hopefully, it's pretty correct and reliable. So Dan has been leading a bunch of hardening efforts on that code base, which is currently in the Avalanche Go, and then just kind of slipping in fixes as we get it. So just as a reminder, that is alpha level code. It's not really production safe yet, but definitely give it a try and let us know what you think. We so far have been pretty happy with its capabilities, but would love to hear if it is or isn't working for you and why. So that just wanted to highlight as something that's happening in the background. Aaron, maybe you want to cover anything that changed on the C chain and maybe what's coming in the next release.
Sure. Yeah. The biggest change that we got out in the last release for the C chain was migrating in all of the latest changes from Go Ethereum up through V1.11.4. So we're still a few versions behind and still working on catching up. So that's going to be one thing that we're hoping to get out in, if not the next release, then the release after that. But in the past few weeks, we have fixed one regression that came up when we introduced the latest changes from Go Ethereum. So there was a weird behavior that was reported by the Hubble team. So huge thanks to them for reporting this. What they saw was that if they had a WebSocket connection to the C chain that was using the public RPC as we were initially trying out the release, what they would actually get was these empty log events. So these logs are all of the events that get emitted by Solidity smart contracts. And they include things like the block hash, transaction index, and the log index as well as the transaction hash. And what they were seeing was that these logs were being emitted, and actually most of these fields were not populated. So these would be coming out with over a WebSocket connection saying, hey, here are the latest logs that are coming from the most recently accepted blocks, and they were incorrectly left unpopulated. So after we took a look, we found that the reason that this was happening was that there was a small change in some of the Go Ethereum code that we support and use, where it was changing where the derivation of some of these fields was being called. And so we didn't correctly apply that fix when migrating the latest changes in. So it took a little bit to figure out exactly where that change was coming from, but luckily it was restricted only to occurring on WebSockets that were saying, here are the latest logs coming from up-to-date blocks, and it only occurred during that path. So we saw it and we're pretty easily able to track down exactly where it was coming from, and we released the fix in the latest Avalanche Go and their latest release of Core ETH. So that's out now. There was one other regression where the logs were a change in how we were extracting the logs would cause it so that if you were trying to look up the logs that came from an individual block that contained no Ethereum transactions on the C chain and only an individual atomic transaction, then it would result in returning an error because it would look it up and say, oh, there are no logs for this block. And it was actually related to an incorrect check for nil explicitly as opposed to an empty array. So we fixed that bug as well. And so now that will work for atomic transactions too. But yeah, that was where the interesting bug fixes from the last release.
Yep. I think another thing that we've also seen some people discuss is some of the gossip kind of performance on the EVM. And there's been a ton of work on that one that's not in yet, but may be in really soon. So Aaron, I'll pull up that PR and maybe you want to talk a bit about what research is going on there.
Sure, yeah. So in the initial pass that we had for the gossip algorithm that we use for the C-chain mempool, we introduced this a few years ago when we first launched the Snowman++, as people were needing to gossip transactions directly to the block proposer. And so we had a push-only gossip mechanism where basically as you receive transactions, you would push them to some sample of the network. And if you had already received those transactions, you would say, okay, I've already received this, therefore I've already gossiped it as well. And you wouldn't further propagate it. And this would work to reach a decent amount of the network. But what we found in our simulation was, as we got some reports that this wasn't working in all cases, what we sort of realized at some point was this could actually result in a scenario where after you've reached 60% of the network starts to actually absorb that push gossip and stops continuing to gossip those transactions, such that if you are gossiping, it may not reach the last person who's actually proposing that block very quickly. And so what this really looks like is, as soon as you've gossiped to 60% of the network, the chances that the next person you gossip to continues to propagate that gossip starts to go down. So reaching the upper percentiles of 80, 90, 99% of the network being reached and having seen this transaction starts to take longer and longer as it just slows down how that propagation works. And so this is exactly what we found in our theoretical simulation, running through what does this mempool look like when you're simulating multiple nodes, sending these transactions to each other and following this algorithm where they only gossip it if they haven't done so within some period of time. And so in order to counteract this, what we're introducing is both a push and pull mechanism. So this is very normal in mempool gossip algorithms up to this point, where we only had push, which was really just, this is the simplest way to do it. This works for now. So this is a fix for that. And what we introduce is both push gossip using the mechanism that we have now, where we will push as we receive transactions in order to supply it to the rest of the network. And we're also introducing a pull gossip mechanism based off of how Go Ethereum sends transactions, where we essentially say, here is a Bloom filter of all of the transactions that we already have in our mempool. And we'll actually send that to our peers, and they can check and see what transactions they have that we haven't included in that Bloom filter, and then send them back to us. So this way we have some pull mechanism as well. And this means that if you are, let's say, in the 10% of the network that hasn't received a transaction yet, if you send one pull request to anybody that has, they will see that difference in your version of the mempool versus theirs, and you'll actually pull that in. So instead of relying purely on this push mechanism, we'll actually have both push and pull, and it will result in transactions propagating to the whole network much more effectively. So Josh Kim has put this PR up and put up this beautiful PR description, as well as all of these simulations. So if you're curious about how all of this works, this is going through review now. And yeah, this is the mechanism that we're going to use to improve that. And this is something that's impacted a few people who have reported it to us. So yeah, we're hoping to get this out in the next release. Just have to do a few more iterations of review.
One of the nice things for this as well is this is also kind of the start of our spearhead towards pushing VMs to use more standard components and modules. So a lot of the development of the of our Go-based chains. There are definitely some more high-performance mempools which do a very different, basically proposer-based gossip mechanism, or not really gossip, but just like direct proposer issuance mechanism. But for at least the chains that want to have like a globally replicated mempool, this is kind of our goal, is to make this kind of that standard backbone that Go VMs can use and reuse. So we're kind of trying to push more towards having standard components that are importable as a wider push for flourishing out like the development SDK for VMs as well. But yeah, so this will be kind of the first pass towards these modules. So I'm really excited to see how this comes out. Obviously the simulations have come out really well, so I think we're expecting this to go over really well on the C chain side, but I'm also looking forward to introducing this on both the P chain and X chain as well. And I'm sure that the MEV crowd will have fun digging into this as well, because they are particularly interested in any mempool related changes. So yeah.
Yeah. If you look up this PR too, you can see it's using generics where, if we weren't building this out with the specific intention of using it on the X chain and P chain and as well as future VMs as a component, we probably wouldn't have made that decision. But this is, our first pass at starting to build this out as VM components that will be easily shareable. For probably one thing that actually probably helps us in terms of building these generalized shareable components is the fact that the X chain, P chain, and C chain are all relatively different in how they work. So they sort of force us to think about higher level abstractions and how we want to support that. So one example of this is that for the C chain, we support transaction replacement in the mempool as well as dependent transactions being issued. So as an example, this basically means I can issue a transaction on the EVM, or let's just say the C chain with nonce 5, and then I can also issue transactions with nonce 6, 7, 8, 9, and 10. And all of those will be held in the mempool, and all of those will be, thrown into a block as soon as it makes sense. Whereas on the X chain and P chain, we don't actually allow dependent transactions to be issued. So building out this abstraction right now, this is very much focused on the C chain, on the EVM's case. But we'll have to figure out exactly what the abstraction that we can share between mempools that actually want to make slightly different decisions around this. I don't know, Steven, if you have some thoughts on that.
My thoughts are just that mempools are hard and DOSy resistance is harder.
Sometimes mempools are different. Yeah.
Yeah, I think that there's been a very long outstanding kind of issue with Ethereum's mempool around like DOSy stuff, specifically with respect to like both dependent transactions and also transaction replacement are two properties that make it very hard to have a DOS resistant mempool. As might become a theme in these talks, I talk about DOS resistance a lot. But yeah, so definitely trying to keep all of that in mind as well. But yeah, mempools obviously have different goals and different nuances. So yeah.
When we're talking about that strategy too, for people that haven't really like ventured into this area much, the idea with the mempool, right, is like you're letting nodes exchange transactions that may end up in a block, but may not, right? So if you have the ability to manipulate the mempool in a way such that you can get away with getting a node to like execute data and then not include it in a block so you don't pay fees, that's the cycle we're talking about, right? And so as we're going into more advanced mempool design, like what are the ways to consider how you actually prevent that in a gist? And like the worst case would be that if you can do that in a block, that forces you to now replicate that through the entire network. So like there are things that you're talking about with like optimistic execution of data that may not be able to pay fees. Then you're getting into like how you actually manage the mempool internally to try and defend against this. So it's quite a active area of research, right? Like you want to avoid sending data to people that's not going to get into blocks. Like there's a lot going on here, but this is the hope here with what a tool like this is when we're talking about it being used generically is that for within the Avalanche ecosystem in its entirety, time can be spent on actually implementing something like this once that may be very complex or difficult. And then any of these virtual machines can just rely on that instead of all having to re-implement it slightly differently, which makes it, dramatically harder to maintain and everything with that. So, the hope here is that for anything that's shared across blockchains, like shared problems, really, that there's a shared package that can be imported wherever you may be using it. So,
yeah, and right now this PR is very much in a do as little as possible state in terms of not dealing with any of those things about dependent transactions or transaction replacement. So all that it is just takes an injected dependency, which basically just says, here are all of the transactions currently in my mempool, and then only deals with handling the gossip of it. So what it is right now is fairly easily portable over to the XMP chain. And then the abstractions that we're talking about beneath that with transaction replacement, DOS resistance in the mempool, that gets more complicated, would probably be a module that you add on top in order to support the different types of features you might want in a mempool. And ideally people can make their own decisions about that, or will definitely make their own decisions about that for the XP and C chain, and provide support for people to use whatever they want when it comes to their VMs.
Yeah, cool. To go back a bit just to the release, the other PR I wanted to call attention to that got merged in was from an external contributor on the proposer VM window. So maybe one of you guys can talk about what's going on here. I think we talked about this a bit last call, so I don't think we need to go too deep into it, but maybe just a quick reminder now that it's merged.
Yeah, so I think that at the end of the last call, we were talking about whether or not it might make sense to have a minimum eviction window, and whether or not like the time-based eviction still made sense with the reduced queue size. So I think that at the end of that call, we had decided basically to basically merge this PR as it was. So this PR should reduce the number of diffs that need to be applied in order to verify warp messages. And then there was actually a follow-up PR that also capped the eviction at a minimum size. So we would always have at least some minimum lag for the proposer to choose their like optimal height at. So all of this is kind of with an eye towards optimizing the BLS warp verification path through warp messaging. There's also another PR. I don't know if you picked this out as trying to be a segue, then we use it as a segue as well. Before I segue at all, I want to say huge thanks. I'm not going to even try to pronounce names because I have this there's funny
It's
story
just Nathan. Nathan.
Oh, okay, Nathan. I do know how to pronounce Nathan, by the way. I just don't know how to pronounce his GitHub handle. But I have this hilarious story when I was a kid about how I had to literally read out a list of 100 kids' names, and I butchered probably 95 of them. It was a hilarious story, but probably doesn't really fit here. Anyways, but yeah. So, anyways, big shout out to Nathan for addressing this. He's been going through kind of our like good first issue backlog, and has really been keeping us on our toes with external PR review. So I would like to apologize to Nathan for any slow reviews, but I would like to thank Nathan for all the stuff he's doing, because it is really great. But keeping on the theme of warp BLS verification, we also have another PR that's kind of a longer standing PR around how we actually index validator height changes and public key changes on the P chain for the key diffs and weight diffs. So that PR is getting pretty close to being in a kind of like end spot. I think that at the end benchmark, I think that's the one. So I think the latest benchmark, if you try to call the get validator set at API on the P chain, it would probably take probably around like a minute to actually generate the Genesis validator set. And with this change, it generates it in around 2 seconds on mainnet from the current height, which is like, some millions of blocks all the way back to Genesis. So we can definitely see that the rate at which we're able to process these disks is significantly faster. And we also did a bunch of optimizations around like reducing lock contention and things like that. So now actually, if a chain were to try to generate the BLS validator set, or the validator set along with BLS keys at a given height, that's actually unrelated to the context lock on the P chain, which is a big contention around having multiple chains generate these heights, and also the actual P chain just updating itself. It does still grab a read lock, where the right portion of that lock is grabbed during block acceptance on the P chain. And I don't think that that's going to change until we Merkleize the P chain state. But all in all, I'm pretty happy with the state of this. I think for all of the warp verification logic, we have to be considering the worst case time for all of our like gas calculations. So there's a pretty rich space for caching improvements along these height diffs. But I don't think that you can really rely on caching for the actual end cost calculation for the warp verification. So I think at this point we're getting pretty close to being being ready to kind of tease this kind of mega PR out into smaller PRs and start merging them. So I'm not sure how many DB changes and migrations we want to include in a single release. So I would say that this would probably hit our allocation of 1 if we were to merge it. So we will probably end up actually increasing the cadence for our releases, at least for the short term, because we have a number of different DB migrations and changes planned. So in this release that we just did, 1.10.4, we had the X-chain pruning cleanup. We're also going to have some P-chain height indexing that gets added, along with some proposer VM indexing for both the P-chain and the X-chain. So and along with this on the P-chain. So we have quite a few database changes kind of flying around right now. And so rather than kind of like slowly releasing those over like a 2-month cadence, we're probably going to increase the kind of like the release cadence and kind of get these out as individual point releases, but in still a reasonable timeline, because they are kind of all getting pretty close to ready to go. So, yeah.
Yeah, I think. Go ahead, Darren.
Oh, I had one other shout out, another thank you for Nathan, because he also made a PR on Subnet EVM to help clean up an old issue that Dariush created a while back, where there are some Go routines being leaked in their core package. And those were core tests. Some of them were actually coming from upstream from Go Ethereum. So after he made that PR, went back and forth a little bit on a couple of reviews, but got in really quickly. So huge thank you to that, or to Nathan for that. And then Dariush also made a PR to fix that, as well as a few more issues on Core ETH as well, and also made a PR upstream to Go Ethereum, which got merged too. So thanks for kicking that off to clean up some code there, Nathan. It was also using a kind of a cool, or Dariush's PR was also using a cool Go routine leak detection package from Uber, which I thought was cool to check out. And that's included in Go Ethereum as well now. So yeah, thanks again.
Uber's Golang packages are super underrated. So highly recommend, if you write in Golang, check out some of their stuff.
I mean, they're not underrated. Uber is like the Golang, or besides Google, they're like the Golang team. Their style guide.
What's funny is that, like, even more so than Google, I think there's a solid argument for it, because like although Google literally like made and maintains Go, you have like so many packages that like may have been started at Google but are now like not maintained. So I'm specifically talking about GoMock as an example, where that started out as a Google maintained thing, and now like that is just unmaintained, and they're like, yeah, use like Uber's fork. Like that's like pretty good. I also love Uber's Zap logging. It is, we originally had like our own like bespoke logger. It was like, this is like pretty fast, like this is fine. And then after playing around with the Zap stuff, I was like, ooh, I like this. This is nice. So yeah.
They also have extremely detailed benchmarks of their logger versus like everything else out there, and nothing is anywhere close on anything. And they are accurate benchmarks as well. It's not like arbitrary or anything. It's I
think that's primarily because they just are like super like aware of anything like reflecty or like type assertion, type reflection, like anything like that, which is incredibly common in a lot of loggers and is like incredibly slow. Also, they're really detailed about any memory allocations, which obviously comes out to be incredibly performant. But yeah, huge fan of Zap.
Yes, I mean, I think one thing that would be maybe good to go into next is some of the height indexing stuff we're doing and why. So like height index bootstrapping, or like maybe just really the height indexing changes to the database, and then what that may allow us to do. I don't know if there's a PR that you want me to pull up while you talk about that, or if it's still...
There's one PR that's called like it has like AVM in the name by Druba around like implementing the height index goal. Yeah, that guy. This is one example of them. So when we were first writing the consensus engines, it was primarily the Avalanche consensus engine first, and then the Snowman consensus engine was really thought of as a derivation on top of like the Avalanche consensus engine. So essentially, you can very much think of Snowman as Avalanche, but just with some more restrictive conflict set management. And so that's how a lot of the consensus stuff was originally implemented, including bootstrapping. And what that meant is that you can really only, or you really can't do too much by height. So there is a notion of height on a DAG, but it's not as useful of a value compared to a height on a chain, right? Because a height on a chain exactly describes the block, whereas a height on the DAG, is basically specifying some cut of the DAG, and like what that actually means is sometimes not that useful. So pretty much all of our consensus stuff when we first launched had pretty much nothing to do with height, except for some minor in-memory optimizations for like the processing frontier. But now that we're kind of fully chain-based, we can really use the height-based lookups to be a lot more optimized for some of the things that we're doing, in particular bootstrapping. So the way bootstrapping works right now, so when you first join the network, you have to synchronize the state of the network, and that initial synchronization is called bootstrapping. And the way it works is essentially you perform a consensus operation to get one of the recently accepted blocks, so say the last accepted block, and then you just follow parent pointers. So you look at the parent hash, get that block, get the parent hash, get that block, look at the parent hash, and you recursively perform this. And there's some optimizations. So we have this like get ancestors message. So rather than just looking up one, we actually fetch like a range of blocks. But it's not parallelizable because you can only know like the next parent. So you have to get some like chunk of blocks, verify them, and then move along. So the idea that we want to do for bootstrapping in order to kind of like speed up this process is rather than just getting the last accepted block, we can get different blocks at different points in the chain and then start syncing those concurrently from that point. We still have to rely on the parent ID to actually provide inclusion and know that that is one of the blocks that was verified. But you don't have to have this single like process going on. And so we're in the process of introducing this height index to some of our chains that didn't have it before because it wasn't needed before, specifically on the X chain and the P chain. The X chain didn't have it because it was a DAG. And when we linearized it, we actually introduced it to the block portion of the VM. So the new chain, as it was moving forward, was indexing heights. But this is actually a PR to kick off the background indexer for the proposer VM portion of the X chain heights. And then there's going to be another follow-up PR that introduces P-chain height indexing, which will go through all of the blocks on the P-chain, index their heights, and then kick off the proposer VM index for that as well, all kind of with this eye towards some bootstrapping improvements down the line. So yeah, I think that's kind of the main point here. There's also a bunch of different other things that height indexing is used for example, state sync and things like that. But for the right now, we're kind of focusing on it being for the bootstrapping portion.
Yeah, I mean, I think the thing to keep in mind here, right, is as the network slowly, so like there are two like parallel tracks to how Avalanche seems to be developing. One of them is like the maturation and functionality on the primary network, which has the security of the entire network, has the P chain, X chain, and C chain. And then there's this entire other aspect of development, which is the growth of subnets and then how subnets communicate with each other. And if I could like separate our like two work streams, it's really those two things. Now, the benefit with some of this and what we're working on is like for the subnet specific track, what is like the fastest we can get a node up to participate on a subnet? Because a lot of times, like when people are looking at subnets and how they compare, it's like, oh, I got to synchronize all this extra data. I got to like sync the entire primary network. What can we do to really minimize that without giving up the ability to communicate with the rest of the network, whether that be via warp or some other mechanism? So a lot of this work is kind of directed towards that. But then on the other side too, if you're bootstrapping the entire network and it takes you a month, it's probably not good enough if you're running an archival node. So like what can be done in that case? And, I think there's a few teams like Aragon and Reth that have pioneered totally different ways to like synchronize an archival node, which are super interesting. But even in the case of non-archival, how fast can you join the network? And, at least my vision is, hopefully in the span of a few hours, you can fully connect instead of even like a day or something like that. So, as we move closer and closer to that, we're going to keep experimenting with different optimizations to that sync process that will allow us to do that. So, the C chain performs state sync, but the X and P chain currently do not. They still sync the full thing from scratch. And so as we migrate to the Merkle DB, it will allow us to transition, which will be super, super nice and immediately felt by people actually using the network. The trade-off with that is blocks, really, and how blocks are stored, managed, and fetched. So a lot of people assume that all blocks that have ever happened on the network are always stored on every node and fetchable in their entirety. But that requires a lot of things to go on at the same time for that to work, right? So then, if you state sync, you're going to have to go backwards and actually go iterate and fetch all the historical blocks that have happened and bring them back so that if anyone ever requests them, you can serve them. Now, that obviously requires a ton of additional storage to do, especially in like high throughput chains that are processing like 10 to 20 megabytes per second of data. So, you may be interested in the idea of what a network could look like without that requirement. But this is definitely more in the line of assuming that is a requirement and we do have all the blocks. What's the fastest way we can actually go fetch them all?
Yeah, I would also like to point out that for something like the light VM, where you have basically these like Merkle inclusion proofs and you're like trying to have this stateless VM design, you very explicitly can't store all of your historical blocks because the historical blocks very explicitly include the Merkle inclusion proofs of all of the key value pairs that are touched in order to process something in the light VM, which would mean that, in fact, if you have all of the blocks, you are, in fact, an archive node. So in order for something like the light VM to actually reduce your disk overhead, you very explicitly have to prune old blocks. I'm very much of the camp that blockchains don't scale unless you like evict old data at some point, including blocks, at least for validators. But it's definitely something that is very important to keep around, at least on some number of archival nodes, very much in at least one kind of thing, so that you don't lose the history of the chain. But yeah.
There's a lot of philosophical conversations that we could get into with this, which is, if you don't actually re-execute every state transition, how can you be sure that the chain is correct, right? And like, so you do relax some changes here where like you assume that the current state of the network is serving you a state route that was then eventually processed correctly, right? So you aren't actually making all the changes that get you to that point. You're just getting that and then going forward. So this is a very different approach, but as like throughput increases, as the chain gets bigger, you make that trade-off, right? And so the hope is that you can still allow people to do a full sync if they want. And that's really a lot of what like this full bootstrapping optimizations are. But for people that maybe are not interested in that or don't validate the primary network, it should be, you may not need all those blocks because no one's ever going to ask you for them. So there's a lot of conversations to have here related to this. And the one caveat I will throw is some integrators, like whether that be data providers or exchanges, require full transaction, like full block history, and do actually verify everything from Genesis. So there is also a trade-off there, is that unless some of those integrators change their policies, that like the implementation path is not necessarily, is kind of bound by them sometimes. So something to just consider.
Yeah, I will say, like, you know, the logician or whatever in me, or like, you know, kind of thinks that like a full sync doesn't really make that much. You know, it's like at the end of the day, you have, you know, security via Twitter, right? It's like if you have some Merkle root and you assume that the cryptographic proof of the Merkle root is valid, so that's a very key assumption, but like we assume that public-private key cryptography is valid and so on and so forth in the rest. So assuming hash functions used in the Merkle DB are fine. And assuming that people aren't rioting on Twitter saying like, hey, my node isn't making progress anymore because like someone just like accepted this block with an invalid Merkle root, and your Merkle root is the same. You know, like if those three things happen, then like it's pretty much guaranteed that there couldn't have been anything invalid that got slipped in. But yeah, I definitely think it's a nuanced conversation, and to Patrick's point, sometimes it's not necessarily just like what you think, but it's also like some integrators have a policy, and those things can be very important. So yeah,
Much to consider. I think, and to be clear, like I think this is where like some of the flexibility of subnets is so useful, is that you can, the community that runs a subnet can make this decision. There is no enforcement by the network upon any of this. So, you know, some particular use case, which I always talk about, is like, you know, data indexing, right? Really, the chain in that case is almost used as like a DOS resistance mechanism and just data distribution mechanism. But frankly, I don't really care what you like indexed 3 weeks ago. So I'm just going to get rid of it. And I'm just going to process the current state and make sure you're paying the requisite fees. But then like some extremely high value chain, which is maybe extremely financially oriented, where you need reporting for all time, well, then maybe you would never consider deleting any data or even re-execute everything, even if it takes time to do that. So, but, you know, I think that's an interesting thing for people to think about as they're playing around with this. So let's see, what would be another, I don't know if Stephen, there's another topic you wanted to chat about. I don't know if we were talking, I think we already kind of covered the push to pull gossip one, so I'm not sure we want to go back into that. But there was a question, or unless you have something, there are some questions people asked that we can get to.
I think just the only comment is I think we're probably going to be incorporating that push-pull mechanism into some of the consensus distribution of blocks as well. So currently we periodically push blocks out to people, and I think in some of the testing of the HyperSDK, we saw that was a pretty heavy-handed way of disseminating information. And so rather than pushing a bunch of information to try to get that last quartile or last percentage of nodes to see the most recently accepted block, we'll just kind of switch to a periodic pull-based mechanism. So I think that was kind of the only comment there. But yeah, I think we can probably go into some questions.
There was one I almost forgot to talk about, which I don't know how, is that the company also released a alpha level version of a mnemonic Shamir secret sharing tool, which is pretty cool. So for those that aren't familiar, you know, I guess I'm assuming people are familiar with crypto secret phrases. So let's just assume you have your 24 words or 12 words somewhere, right? And most people will back that up directly, right? Like, you know, you write out a piece of paper and shove it in a vault, or like, you know, whatever you do, maybe you just memorize it. But sometimes what people want is to say, well, it'd be great if maybe I could separate that out into little pieces and then put those pieces in different places. And then if I could maybe at some point in the future got like some portion of those pieces, I could get my word back, so that if someone was to compromise any particular part, they couldn't steal your funds. And so this is where this tool comes in handy, which is, you know, drop your 24 words in on, you know, there's a lot of pretext here of like running this on a secure computer, disconnected from the internet. We don't make it, just be careful. This is still something we're playing around with. But the idea here, the finished product, the idea is you got your 24 words, you put them in somewhere, it spits out any number of sets of 24 words. So maybe it turns your 24 words into 5 pieces of 5 sets of 24 words. You store those in different places. And then if you get 3 of those 5 sets together, you can regenerate your original words. So this is a very cool tool that I think there are some, other implementations of this out there. So, this is not the first one by any means. But it is a very minimal version of this that is written in C++ that you can run in almost any environment. There's no UI, it's just a command line. So if you're looking to play around with this sort of technology, this is a great place to look at and contribute to. Like I said, it's all in C++. So if you have wanted that Avalanche node in C++ and want to do something Avalanche, but haven't been able to because C++, this is the place to look, I guess, for that small set of maybe 3 people that I'm talking to.
I would also like to maybe narrow it down to an even smaller set of people. I would also like to say that Shmir secret sharing in general is actually a pretty, I would say, accessible cryptographic primitive. Like reading the paper is actually not that bad, even without a cryptographic background. And so if you're interested in kind of like learning about how this actually works, I actually would say that this is a more approachable cryptographic primitive than most. Most are like, okay, this is a lot, but this is really not too deep. So if you're at all interested in like getting into like cryptography and so on and so forth, I would definitely recommend just kind of like reading about how Shmir secret sharing works. Yeah.
So yeah, I think this is a fun one to play with especially for cryptographic stuff. We're slowly, now we have this, we have a lot of like a multi-signature BLS stuff. We'd like to do, threshold BLS stuff. We have some multi-party ECDSA stuff we're looking at. So the hope here is like, can we provide, there's a lot of different people that use blockchains these days, and what can we do to really help, those people interact more safely or within the parameters that they're interested in. So, fortunately, Ava Labs maintains its own wallet. So we have a vehicle to like actually deploy some of these things into, where people that don't have their own wallet you kind of can't play around as much with these sort of ideas. So yeah, should be really cool to see. So let's get to questions now, because I think there's some interesting ones. The first one actually is from Noah at NodeKit, who actually asked a really interesting question that could dovetail into a bunch of other things, which is, when will you be adding gRPC for subnets? Similar to Cosmos SDK, it's a must-need feature for my HyperSDK subnet. So this is a very interesting question, because there's actually already gRPC connected, but it's in a way that the HyperSDK hides. So let me back up a second. So let me actually pull up Avalanche Go's proto files to show what's going on here. It's in the, I'm going to share my screen again if you guys can allow that in the background. All right. So in Avalanche Go, we have this proto directory that includes all the protos used by Avalanche Go to communicate both on the network layer with people, different peers that don't require deterministically encoded data, and to communicate with custom virtual machines. So Avalanche Go, will orchestrate some binary, in this case, let's say it's some HyperSDK based virtual machine, and then communicate with it over a series of gRPC servers. All of those are defined in this package. So if, for example, the VM proto, you can see, initialize, set state, shut down, tons of different things here that connect. So this is the equivalent of kind of the gRPC layer between like a Tendermint and a Cosmos SDK, but much lower level. So there's a lot of other stuff you can do with this interface that you would not typically be able to do with the Cosmos SDK. You have full control over networking. You have full control over like all of these, like when you build blocks, how you like actually respond to different requests from the consensus engine because you manage all of state. And so the HyperSDK actually wraps this and communicates with Avalanche Go over gRPC on your behalf. But the question, which is interesting, is what if you want to use the higher level format that the HyperSDK provides of blocks, transactions, everything like that, but then have another server on top of that that maybe is in a different language or uses something to then communicate with the HyperSDK via that. And so then it like stuffs block data and then calls out when you want to verify stuff. So interesting, you know, like from an efficiency perspective, I would say suboptimal, obviously, because now you have like 2 layers of gRPC going back and forth on your machine. But I just wanted to clarify first that like there actually is gRPC. That is how custom virtual machines work. Which is good that you didn't realize that, because in the HyperSDK, that means we're doing our job and that you would have no idea. But the point about using a higher level virtual machine interface that's provided by Avalanche is interesting.
I think one interesting thing as well is how we actually expose APIs through the VMs. I'm definitely pretty interested in exploring how best to expose like a gRPC API. And that is really more of just a conversation about how best to like register these services and like sandbox the service definitions and things like that. So we definitely have a couple of people eyeing on how best to have that set up. At one point, I was actually digging into the gRPC Go library and like how to like register an HTTP handler for this stuff. And as far as I can tell, that code does not necessarily work. It's marked as experimental, which apparently is extremely experimental. Or maybe I was just doing it totally wrong. But I think, yeah, it's complicated stuff. I think it typically for gRPC, they use their own HTTP and like HTTP2 stack and like network stack, whereas this would have to piggyback off of the Go standard lib stack, which is different for sure. But yeah, so definitely interested in introducing gRPC in a couple other areas as well. But yeah.
Yeah, I mean, I think one thing we had talked about previously, just because I wanted to make sure we brought it up, was like how the proposer VM is also delivered is really interesting. So right now, like that proposer VM component, which handles Snowman++, is not made aware to the virtual machine and orchestrated by Avalanche Go. So really, Avalanche Go is actually wrapping the blocks that you give it from your virtual machine in another block. It'd be really interesting if we started to pass that on to the virtual machine, and the virtual machine actually had to deal with the ordering or like preferred ordering of things, because then it would be up to the virtual machine to potentially implement like crazy ordering schemes. Like you could have a world where like one particular example that would be really efficient would be if one node, for example, or a set of nodes are the only orderers, right? Like you could have one node that just orders and then purposely like exclude any node that is proposing a transaction that was not ordered by them. And then everyone else just verifies. You could have extremely high throughput. It'd be interesting, right? Yeah.
Totally other side of the world, you could go where you
no
could
one
do
can
like
propose a block. Yeah.
But you know, I know some people have been very interested in, as an example, like a proof of work proposer mechanism. So that currently is technically possible by like doing a proof of work issuance and then like encoding that inside the proposer VM with Snowman++. So that is still technically possible, but a lot of like bells and whistles for nothing. But if you were to like push that in, it would definitely make it more easily and natively supported for, as an example, proof of work issuance and things like that, which not necessarily recommending that because you still have to have the proof of stake consensus because it's still using Snowman consensus at the end of the day. But you know, you can.
I mean, it's cool.
Do that.
You could do like leadering with proof of work and then still get the finality benefits of a proof of stake system.
This is actually getting dangerously close to some of the BCH like post consensus world of Avalanche. Yeah, if you were to go down this route, for sure.
So much to, I think it'd be super fascinating, but you know, we'll see how close we end up getting to that. We're kind of researching different optimizations we could do on the proposer VM and Snowman side in general, and so want to be cautious of putting too much on the virtual machine until there's clarity on how that may evolve. But as much as we could talk about this all day long, we are running up on time here. So Gabriel, I don't know if you want to come back on and help us wrap things up.
Hey, everybody. Yes, incredibly interesting conversation. That was interesting that Stephen touched upon the BCH post-consensus thing. I believe you were talking about what's going on with eCache. That's also very, very interesting, where they're using Avalanche consensus for pre and post consensus in concert with Nakamoto consensus. But real quick, before we pass the microphone around one last time, I very briefly wanted to mention academy.avax.com. So one of the things that we've been has been requested for literally years, as long as that Avalanche has been around, is a more formal way for developers to become Avalanche developers. Obviously, we have documentation, we have meetups, we have hackathons, we have chat rooms, etc. But people were asking, is there some path that is sort of approved by your engineering squad that we can go along and we can really understand Avalanche, the platform, Avalanche consensus, and all of the tooling that goes around with it. So we have recently launched academy.avax.com. And really, there is a guided path towards learning about building on Avalanche. And it has unified resources that were scattered across the docs, across Twitter, across YouTube and Medium. So as I mentioned, this is one place where people can go and learn how to be an Avalanche developer. Currently, there are 2 courses live. We have Avalanche Fundamentals. So this covers consensus, subnets, and virtual machines. And there's also Subnet Architecture. So this covers the benefits of subnets and hands-on Avalanche CLI usage. And in the works right now are 2 more courses. We have Customizing the EVM and HyperSDK. So currently the Academy is in beta, and we would really love to hear feedback from people. So please go check out academy.avax.com, play around with it, and give us your feedback. Okay, thank you again, gentlemen. I want to pass the microphone around one last time for those final thoughts. Let's start with you, Stephen.
Yeah, thanks, Gabriel. Yeah, on my side, just looking forward to the next couple Avalanche Go releases. Again, should have a little bit of a higher clip than usual as we get these database indexes out. And yeah, just looking forward to continuing talking all things Avalanche. Thanks.
Awesome. Thank you, sir. Aaron.
Yeah, just want to say huge thanks to Martin from the DevRel team, who's been working really hard on putting together the Avalanche Academy. I know there's 2 courses that are still coming out that I'm really excited to see both of them. The next one coming out, I believe, is Customizing the EVM, which should be really exciting. So yeah, really looking forward to seeing the community's feedback from that.
Thank you, sir. And Pug.
Yeah, HyperSDK is happening, so working on that. Big achievement. One of our interns for the summer, Sam, has been working on the WASM component for programs, and we got our first token WASM, Rust-based WASM contract running. It's pretty cool. So we're cleaning up. There's a lot to do. This is just very early, but it's really cool to see WASM applied to this and like what it lets you do in this context. So shockingly, like WAS0, which is like the Golang native WASM runtime, is really fast, like way faster than I thought was possible for this technology, especially having done some experiments between like some of the other like Rust-based WASM frameworks that you have to like use the CGO interface and FFI into from Golang. WAS0 is wicked fast, so highly recommend checking that out if you're playing with WASM. It's not ready for this use case. You have to do much more stuff around it to like limit execution and whatever. But sorry, we're wrapping up, not having another conversation. Talk to you guys later.
Awesome. Thank you, guys. Okay, so as I mentioned, my name is Gabriel Cardona. You can find me on Twitter at CG Cardona. Also, please check out Avalanche Developers. That is one word, Avalanche Developers, if you want to stay up to date on what is happening across the latest and greatest from our engineering squad. This happens bi-weekly, so that's every 2 weeks. So we will be back in 2 weeks. If you didn't get your questions answered, or if you thought of a question while you were watching this, please tune in 2 weeks to have a chance to sync with these guys again. So thank you, gentlemen. We'll see you guys in 2 weeks. Cheers.
Thanks.